Hello everyone, my name is Shivam and my teammate's name is Srivatsav, and this particular video is about the demonstration and presentation of our project for the subject of CSE564 Visualization and Analytics at Stony Brook University. For the project, we have made an attempt to create a dashboard for earthquake analytics. With the help of this dashboard, we tried and we aimed to gain some insights about the occurrence of earthquakes and recognize some patterns over the last 6 decades. We have also tried to find out the locations and regions which are very much prone to the occurrence of the earthquakes, and also we have tried to find out the correlation, whether a direct or inverse correlation between the features that we have observed in the past 6 decades for these earthquakes. The The data that we initially collected had more than 25,000 records, and in order to make this visualization more efficient, we reduced it to about 2,800 records with the help of cluster sampling, which is also known as adaptive sampling. For the purpose of adaptive sampling, we first determined the most significant features with the help of principal component analysis, and then we did some clustering on the data, and we did this clustering on the basis of depth of the earthquake, the magnitude of the earthquake, and the latitude and longitude of the origin of the origin of the earthquake. We determined that the k, which we set as when we set k as 4, that turned out to be the best case with the help of Elbow method. And then from these 4 clusters, we randomly selected 700 entries from each of them, and we eventually ended up getting 2,800 rows for our visualization. From this adaptive sampling and randomly choosing the entries, we got to know that the distribution of our data does not change much. So that makes this random sampling very much close to what it will give us much more closer to the accurate observations that we were expecting from the original data. As you can see in the two choropleth maps, that the choropleth maps there, they pinpoint the exact locations of the origin of the earthquake. And if you carefully observe them, you can see that the region of the world which are very densely populated with those red dots, they are still densely populated in the second choropleth map, which has been made after sampling through the data. And the region of the world which were not very prone to the earthquakes and had very less amount of those red dots from the original data, they still have lesser amount of red dots in the data which we collected after sampling. And similarly, we also have our distribution plotted in the through the parallel coordinate plots, and even there we can see that the distribution has not changed much, and the lines and the edges that are there, they have just become a little less denser as compared to the one which we had made before sampling. Apart from this, we also added 2 more features to our data, and those 2 features helped us to visualize these categorical variables even better. The features that we added were firstly the intensity of the earthquakes. We categorized those earthquakes into 3 categories, namely low intensity, medium intensity, and high intensity earthquakes. And the other feature that we added is the decade, which helped us to observe a pattern in the occurrence of these earthquakes in over the last 6 to 7 decades. Now let's move towards the dashboard. Our dashboard has 5 graphs. The first one is a pie chart. The second one is a parallel coordinate plot. The third one is a bar chart. Then the fourth one is a scatter plot. And the last one is a choropleth map. The first pie chart basically shows that what is the distribution between the different types of the earthquakes, and what is the distribution of those intensities. So the low intensity graph, as you can see, the low intensity part of this pie chart is colored in red, and most of the earthquakes are in red. Most of the pie chart is covered in red color. Then second is medium intensity, which is right now 598 in count, and third one is high intensity, which is 95 currently. The second graph is a PCP chart between magnitude, depth, latitude, and longitude. The third, which is a bar chart, has the x-axis, which has all the 6 decades that we have analyzed these earthquakes for. The fourth graph, that is a scatter plot, it is between the magnitude of the earthquake and the depth from the surface, and which basically has the origin of this earthquake. And the last one basically shows the location of the various earthquakes in a world map. Now let's talk about the interaction. Each arc of this pie chart, it is clickable. Now, if I click, let's say, on this low intensity area, then all the other graphs, they get updated according to the, as soon as I click in this low intensity area of the pie chart. Now, in order to reset, we have to click this blue button, which will reset all the graphs. Now let's try with the medium intensity. And now let's try with the high intensity. The PCP here, it has the brushing enabled, so that means I can go to any axis and select an area I want to view in focus. The bars in this bar chart represent each decade, so if I want to visualize any particular decade, then I can simply click on that bar and all the other graphs will update according to that decade selected. We also have brushing enabled in this scatter plot. So that means if I select this area of the scatter plot, all the other graphs will get updated according to that area selected, and I can move around this area to have that feature enabled again. And finally, this choropleth map has this year slider, which basically enables me to select any year. And according to that, let's say if I want to visualize the earthquakes in the year 2000, then I will simply make this slider go at the year 2000 like this. And there are all the earthquakes. So that means that the year 2000 had medium intensity 12 earthquakes and low intensity 24 earthquakes. Now let's talk about the insights. So the first insight that we gain from this from this world map is that the most of the dots are accumulated around this area. This area is known as Pacific Ring of Fire, and this area is the most prone region towards the earthquake. Then the second insight is the second most prone area for the earthquakes, and that is this southern part of America. The third insight comes from this PCP plot, which is like if we select the the deeper depths, we get to know that most of the earthquakes that occur deep into the Earth's surface, they have comparatively lesser magnitude as compared to the overall scale. The fourth insight comes from this bar chart, which tells us that we are observing an overall decrease in the trend of number of earthquakes over the decades. Now, the fifth insight comes when we click on this bar chart of the 1960s, and we get to know that most of the earthquakes in 1960s decade occurred near the surface of the Earth. But as compared to the other decades, if we select any other decade, let's say I select 2000, then we get to know that most of the earthquakes have occurred deep into the Earth's core, and similarly for the 2010s decade as well. So this was our project and the demonstration for the dashboard. Thank you.